Hi, everybody. My name is Krishna, and I'll be talking about PyVelox, which are our Python bindings for Velox. How many of you here have actually built Velox from scratch on your machines? All right, that's great. How many of you have ran into some build issue while doing that? Okay, that's not so great. So PyVelox is like to help you folks explore Velox and play with Velox without having to face the frustrations of building in C++ and dealing with all the pain that comes with anything C++ related. So oh, it's not. It's not working. Oh, there we go. All right. So why? So PyVelox has a simple and intuitive API. It uses Python bindings. It's really easy. Anybody who's been in the Python world knows how things work. Very straightforward. You don't have to deal with types. You don't have to think too hard. It just flows naturally. And any problems you deal with, you'll deal with at runtime, right? So the audience we're targeting with this is like database and data processing systems engineers, like folks who want to integrate Velox into their systems, be it Flink or Query or something internal, and you want to play around with or explore Velox or try things out before you use it in some large-scale production system. Pedro talked about this in the morning, and Konstantinos also talked about we are actually using PyVelox in Meta, in prod, in some capacity. So it's not like this is just for play. And you can install PyVelox just like any other package. And the great thing about this is it's available right now. You can just do pip install PyVelox, and you will get a pre-built PyVelox package. Out of the box, you get array integration, you get the full power of Velox, and a bunch of other nice things. And just to showcase that to you, we'll be creating a simple plan right now, and we'll be running it. Okay, so let's take a very simple and practical use case. This is TPCH query 1, right? I've taken the simplest possible case. And we'll write a simplified plan for query 1. And like I said, it's simplified. It's single-threaded. It's one file. And doesn't do any partial aggregation or remote exchange, everything. This is just a simple plan, the kind you read in a tutorial or on a lightning talk. And the hard stuff is left to the reader as an exercise. Right, so here you have a simple query that just reads from one table, does some aggregations on it, some projections, some aggregations on it, a filter, and it does a group by and order by. All right, so like I said, we will have a very simple plan. It's single-threaded. We're going to do a table scan on it, project and filter. So in this case, I just kept it even more simple and done a project, and then we'll do an aggregation, and then we will write out the result to a table, or in this case, I'll just print it out so you can, view it. So let's look at the query first. So to start off with, what are the columns that we need to read from the table? So we identify the columns that we're interested in: return flag, line status, quantity, some of these other columns, right? And we get the types that are associated with them. And then we just create this row type. Now, row is the containing data structure type that contains the mapping between the name and the type associated. And you can see we use like varchar, double states, etc. The next thing is what's the file we are going to use. So in this case, split. I pre-generated this TPCH scale 1 line item table and wrote it out as Parquet. It's pretty straightforward. PyVelox also contains the TPCH connector generator, so you can use that to generate at any scale factor the files you want interested. So you can play around with that too. Um, at some point, maybe later, I'll put a full tutorial or something on this, so you can like write the data out and play, create plans. So in this case, I have a pre-generated Parquet data, scale factor 1. The supported file formats, as I talked about, Dwarf, Parquet, Nimble, all of these are supported. So now let's try and build a plan. So we import from PlanBuilder, the PlanBuilder type, and then we create this PlanBuilder. It's used to create the actual DAG of plans that you need to run. In this case, let's just start off with table scan, and we tell, we pass the schema that we want, and we pass it the file that we want to read. So it generates the splits on that. And then we just ask for the plan node, and we get the plan node back. The plan node itself is just a plan. It doesn't run anything, right? So the next thing we do is, to run the generated plan, we need something called a LocalRunner, which takes the plan, and then we execute it using the execute command. And you can see like a picture up above of me running this in local Jupyter notebook. So it runs, executes it, you can see the output. And at the end, you can also print stats related to the plan, how it performed and stuff like that. So really simple, basic stuff, but good enough for you to play with, to start off with. And next thing we have is, so that's the really basic stuff. And now we need to do the projection. So to get that working, it's as simple as, again, we create the plan, we do the table scan. But this time, as you can see highlighted in the green, we call project, and we pass in the expressions that we're interested in computing. So it will compute these expressions, and we'll need to do this before aggregation. And ideally, if you have any, if you have real plan, you will do partial aggregation along with the table scan. But like I said, this is like a very simple plan, and it's a lightning talk, and I don't have that much time. All right. So the next thing we do is aggregation and group by. So after you have done the projection on the results of that, you can call aggregate. You pass the grouping keys and also the aggregations on them. So in this case, the sums and the averages and the counts, right? So it's pretty straightforward here. Okay, and the final plan is if you squint carefully enough, you can look at the final plan. So you just create the plan, you call table scan, you do a project, and then you do aggregate on it. You call order by, you have the local runner run it, and you can actually see it output all the results and work out. So this is a really nice tool for you to like play around with, create plans, explore and experiment with what works, and without having to go deep into the weeds of writing C++ code and like figuring things out. Then big thanks for all of this to Pedro, who added like most of the PlanBuilder Python bindings, and Jacob for publishing all this to PyPy, and Sri and the folks at Vote on Data for all the coordination and help we got here. And so it's pretty straightforward. You can just go and pip install PyVelox, and we also have the documentation published on all the bindings and all the types and all of that, which is available on the Velox documentation website. And any questions?
I know Velox isn't a SQL parser, but it'd be sure nice to be able to put SQL in PyVelox. Is there any hope for that?
So we use DuckDB SQL parser internally in PlanBuilder. Ideally, we don't want to use it, but for now, we are using that. So it is somewhat Presto compatible, not fully Presto compatible. But at the moment, We have some plans, but I'm not sure how fully materialized they are. So I'll leave that the actual answer to Pedro, and when we will get to doing something like that.
No, just saying that I think the idea is that you want to define things on a physical level. So it's mostly used for debugging when like people developing new engines. So it's not meant to be as simple to use as other data tools. I think usually the problem is if you define things using SQL, then you might lose something on this translation process, right? So I think we want that thing to be as specific as you can. So I think that's why you can define the exact types, the exact splits and everything. So I think the idea is having something that you have full control because you might need when you're debugging things, and not something that is as convenient to users. I think to your point, those are things that we can build on top of that, but I think that's not the purpose of PyVelox. It could be something built on top of PyVelox.
Also, I want to point out this is not like a data frame library. Like that's not our intention. There are many data frame libraries. In fact, we support conversion from Arrow to Velox and vice versa. So yeah.
Okay.
Cool. All right.
Thank you.
Thank you.